Hey everyone, this falls into the category of in case you're interested. So I'm going to use the product rule to prove the quotient rule. So I know there are some subtle mathematical issues with this, but it does prove a point. So say we have y equals a over b. I changed it from u and v just because when I rewrite this, it will cause confusion if I don't. So a and b are just functions kind of like u and v. So I'm going to first rewrite this as y equals a times b to the negative 1. So my u is a, so u prime is a prime. That's the straightforward bit. My v is b in parentheses to the negative 1. I did it this way so you can see the chain rule in action. So our v prime, derivative of the outside is the negative 1 in parentheses negative 2. And then the inside stays the same, times derivative of the inside, so b prime. So really our v prime is negative b to the negative 2 times b prime. So careful because we have an exponent of negative 2 and a prime with that, so it looks kind of wonky. So here's why I switched our u over v to a over b, just so I wouldn't have like u equals u and v equals v to the negative 1. That would be so weird. So that's why I switched it to a and b. Okay, now using our product rule on this, so y prime is going to be u prime, which is a prime, times v, which is b to the negative 1, plus u, which is a, times v prime, which is negative b to the negative 2 times b prime. That's a little ugly. So now cleaning this up a little bit, and I'm going to put this as a prime over b, and then minus, I have a times b prime over b squared. And then I can get, just adding fractions, I can get a common denominator here. So I have y prime equals a prime b over b squared minus a b prime over b squared. So y prime equals a prime b minus b prime, a b prime, squeeze it in there, over b squared. And that's where that derivative of u over v being u prime v minus uv prime over v squared comes from.